So those of you playing along at home, can you see the screen, the smartboard screen? Can you see this? You're good with that? Nice! Love it. I love it when a plan comes together. Except, now I don't have my, I blame Christensen for this. Yeah, excuse you. All right. Hi. How are we? Yeah, yeah, yeah. Excited? All right. So, welcome, one and all, those in person and out there in the virtual land. Yeah, it's math time. I'm not used to this. Is a little different. I'm not used to having people, in the room with me. So for those of you in the room, just so you know, I kind of spaced. I tried to not go like right. I didn't. We could have had everybody up front, but I wanted to space you out as best we could because then everybody's happy and all that fun stuff. So okay. But if you are in class, just so you know, you gotta kind of sit here because I'm supposed to keep track of where everybody's sitting. So for purposes of everything. Okay? All right. So we are going to. You should have at some point in time over the weekend taken the 4.1 summative that was due last night at 11:59. So if you haven't, I haven't even. I'll be honest with you. I ran into a family emergency this weekend, and so I didn't even look at grades until about an hour and a half ago. So I don't know if you did or not, but I probably won't get that in by the time that it's supposed to be in for grades today. So because our grades are due today. So yeah. So here we go with the circular functions in the unit circle. Okay? So what I would like you to do is somewhere in your notes, make as best you can just a circle. Okay? A straight up circle with the crosshairs going in between it and all that fun stuff. Okay? Now we didn't get to it this year yet, but the true equation of a circle is that, okay, where h comma k is the center of our circle. So the equation of the circle that you guys just drew is x squared plus y squared equals 1. And that tells us a couple of things. So the first thing that it tells us is it tells us that our center is at the origin. So the center of our circle is right there at 0, 0. Okay? The other thing that it tells us is that it tells us that the radius of our circle is the square root of 1, which is just 1. So this point out here would be the point 1, 0. This point down here would be the point 0, -1. This point over here would be the point -1, 0. And up here it would be 0, +1. Okay? Because our radius is 1. So then, if we go back to arc length and theta measures, okay? So if we have S equals theta times R, well, S would be our arc length. Theta, let me throw a Okay? So then theta would be right here. And this would be our S. Hi. I got you sitting fourth one this one. Yeah. Yeah. And so if I call my arc length, if I call that T, we'll call that T our wrap value, if you will. Let me get this in here. Here. And let me say, so that's our T axis. So this distance here would be T, okay? And T is the same length as S. If I were to bend that around the circle, we call that a wrap value. Okay? Because our radius is 1, we get T then equal to theta. And I can take different T values. Let me see if I can find a different color. Something that, here we'll go into what this function is. I can take a different T value, like there, and I can wrap that around the circle here, and so then it would be kind of like this. Okay, that would be my T value. And then that would be where my theta would go to. So theta would be there. And then theta would be equal to T, and so on and so forth. And we can do that all the way around the circle. We can even have negative T values. If I wrap that around, it would probably be somewhere right about in there. If I bend that around my circle. Okay? So each and every point on the circle corresponds to an XY point on the, or every point on the circle corresponds with a T value. Side note, I forgot to say, those of you on the line, if you have a question, I do have the chat up, so you can drop one in there, but you can also unmute yourself and be there. Okay? So each T value also corresponds to a central angle theta, whose radian measure then would be T itself. Because theta equals now, in a normal, you guys would have seen most of this in Algebra 2. But, so we're kind of just briefly going through it because of where we want to get to. Okay. So, cosine of t. We're dropping some trig functions on you today. So it's cosine, but the symbol is COS, and then this part in here, that is your angle. Because this is a trig function, and remember the inputs of a trig function are angle measures. Okay? So the cosine of our angle is going to be our x value on the circle, on the unit circle. That will be our x value on the unit circle. The sine of t is going to be the y value of our angle, or of the point on the circle. Tangent of t tangent is going to be the sine of t divided by the cosine of t, or in this case, that would be y over x. So we can find the cosine of any angle by taking the y value from the point that it corresponds to on the circle and dividing it by the x value. Now these next three are new. Okay? Cotangent, secant, and cosecant. I will tell you this. Everything in trig needs a co. Okay? So tangent goes with cotangent. Okay? Sine goes with cosecant because it needs a co. Cosine goes with secant. Okay? And these are the inverse trig functions. I should say inverse trig functions. So reciprocal trig functions would be a better term of it. So cotangent, or COT, COT of t is 1 over the tangent of t. So that would be cosine of t divided by sine of t, or just x over y. So we take the x value of any point on the circle divided by the y value of that point. That gives us the cotangent. Secant symbol is SEC. That, I said, was 1 over the cosine, because everything needs a co. So that is going to be 1 over x. Cosecant is CSC. That's going to be 1 over the sine, or 1 the reciprocal of our y. Okay. Now, in order for all of these to work, it has to be on the unit circle. So x squared plus y squared has to equal 1. That's the equation of the unit circle. It has to be on the unit circle for it to work. Okay? So we want to find all 6 trig values of t. Okay? But the first thing that we have to ask is if it's really possible for this to be working out, No problem. Okay? So what we need to check first is we need to check if x squared plus y squared is really 1. Okay? So the x value of our point would be negative 5/13. The y value of our point would be negative 12/13. So I would take negative 5/13 and I would square it. Add that to negative 12/13. Square it. And hopefully that is equal to 1. So then this would be 25/169 plus 144/169. That's going to be 169/169, which is 1. So that works out. So this point is on the unit circle. So since it is on the unit circle, then, now we can figure out what all of our trig functions are. So let's start with the cosine. Cosine was what? From the last slide, what was cosine? X values. So that means the cosine here is negative 5/13. Sine was what?
Y.
The y. So that means it's negative 12/13. Tangent was what? Y/x. So that means we got to do a little math action here. So that's going to be negative 12/13 divided by negative 5/13. Anybody? Anybody? Remember how to divide fractions? Get that thing out of waste. She was reaching for a calculator.
I was not.
You so were.
I was adjusting it.
Mm-hmm. Anybody? We flip which one? Top or bottom? Bottom one, so we flip it. So then that would be, so this would be negative 12/13 times negative 13/5, right? Negative times a negative is a positive. Thirteens cancel each other out. So we just get 12/5 there for the tangent. Secant is the reciprocal of cosine, so that's going to be negative 13/5. Cosecant is the reciprocal of sine, negative 13/12. Cotangent, reciprocal of tangent, 5/12. And those are your 6 trig functions for that. Okay? Questions? Questions over in the virtual land? All right. Now, let's get down to the exciting part of the day. Okay? So, what I would like you to do is, I got to see if it's on the next one. Nope, order point. Okay, all right. So, we are going to build what's called the unit circle now. So what I would like you to do is, if you are, start on a fresh page of paper, because you're going to use this. This is going to be your guide for the rest of the year. You're going to use this piece of paper for the rest of the year. Okay? So start on a fresh piece of paper. Right smack dab in the middle, draw as big of a circle as you possibly can. Okay? It doesn't have to be perfect, okay? But draw as big of a circle as you possibly can. And we're going to find the sweet 16 points, which are nice points on the unit circle. Okay? So the first one, and then actually draw your crosshairs in it too, because that's going to help you out, because we're going to divide that up into quadrants. We're going to talk about the quadrants. Okay. So we'll start with the easy ones. Okay? So the easy ones is out here. This is 0 degrees. This is also 0 radians. Okay? So that's 0 degrees, 0 radians. The unit circle has a radius of 1. So this is at our point 1, 0. Which tells me that the cosine of 0 degrees is, what's the cosine at 0 degrees? How many? Cosine is x. 1. So the cosine at 0 degrees, or 0 radians, is 1. What's the sine at 0 degrees or 0 radians? 0. Okay. Tangent. What's the tangent at 0 degrees or 0 radians? 0 again, yep, because it's sine divided by cosine. Yep, okay. So it's 0 also. Okay. And then that tells me that the secant is 1. The cosecant and cotangent are undefined. Okay? Love it. So we got that. Okay? Then we can go up here. Up here is 90 degrees, or pi over 2 radians. Okay, if I were to convert 90 degrees into radians, I get pi over 2. That is the point 0, 1. So what's the cosine there? 0. What's the sine there? 1. What's the tangent there? No. Undefined, because we're dividing by 0. Yep. Okay. Okay. Handle? Okay. Let's go another 90 degrees. Go up here to 180 degrees, or pi radians. That gives us the point -1, 0. What's the cosine out there? Cosine at pi, cosine at 180. -1. Sine. 0. Tangent. 0. Yep, because the sine is 0. Yep. So we're good there. Then we'll go down here and I gotta adjust this thing. Okay? So down here would be 270 degrees, or 3 pi over 2 radians, which is at the point 0, -1. So again, cosine. Zero, sine, -1. Tangent, undefined there, yep. Yep. Love it. Yep. So there we go. All right. Now, let's go to the quarter points. Okay. So the quarter points this one came in twice. Okay. So if I am dealing with, so if I go back here one slide, so the quarter points would be, we'll go green. This would be the quarter, there would be the quarter, there, and there. Okay? And the reason we call those the quarter points is because this is half of half, which is 45 degrees, or pi over 4 radians. So that's why we call that the quarter point. Okay? Now, let's show you some math going on here with that. So if I take this and I say that this is 45 degrees there, or pi over 4 radians, okay, that makes this be then a 45-45 right triangle with a hypotenuse of 1, because that's my radius of that circle. And that would make this be the x part and that be the y part if I were to go back here. So basically the triangle that I'm drawing here is right there. And that's the triangle that we just drew. But we drew it nice and pretty on the other slide. Okay. We can find what x and y are because we know our right triangle thing. We know that this is an isosceles right triangle. So x equals y. So x squared plus x squared has to equal 1 squared. So 2x squared equals 1. X squared is a half. Okay. Take the square root of both sides. I can take the square root of both sides. That. Really, it's plus or minus here. And so then x here is going to equal plus or minus. Well, in true mathematics, we don't like 1 over the square root of 2. We would multiply that by the square root of 2 over the square root of 2, rationalize that denominator, and we would get plus or minus the square root of 2 exact rounding. We are an exact, when it comes to the unit circle, especially with these sweet 16 points, we are an exact kind of a thing. So that, if we go back to here then, so this would be the point, the square root of 2 over 2, comma, the square root of 2 over 2. For the point. So the cosine at that point would be the square root of 2 over 2. The sine at 45 degrees, or pi over 4 radians, would be the square root of 2 over 2. The tangent would be 1. Okay? Because y divided by x, they're the same, so the tangent is 1. Okay? Now, I can go over here, and over here it's 135 degrees, or 3 pi over 4 radians. And the points are going to stay the square root of 2 over 2 and the square root of 2 over 2, but the x value, because now I'm in quadrant number 2, the x value is going to be negative. And then I can come down here, and the math is all still going to be the same, except now, so I went 45 more degrees to get to 180. 45 more than 180 would be 225 degrees. A quarter pi more would be 5 pi over 4 radians. Quadrant number 3 has both x and y as negative. And last one, 315 degrees, 7 pi over 4 radians. And that one. Square root of 2 over 2, positive for the x, negative for the y, because we're in quadrant number 4. Good? Good. Alright. Another. We'll go here and then we'll come back to that. Okay? So now we're going to have the 6th point. Because White. So this is 30 degrees, which makes this one be 60 degrees. So now, if I'm looking at it, I'm looking at this point right there. So here is that 30, 60, 90 right triangle. So that's our 30, 60, 90 triangle. So we have a special right triangle to go along with that. We should have learned it a while ago. So the short leg we'll call it is A, because I don't want to use X. Okay? So if that's A, that's what we base it off of, then the hypotenuse is 2A. And the long leg is A times the square root of 3. Okay. That's our 30, 60, 90 ratio. Okay. Well, we know that our hypotenuse is 1, so this side length here is 1, which means then that A is 1/2, right? Because if 2A is 1, then A is 1/2. Which means that our long leg then is the square root of 3 over 2. So if we put that onto our unit circle, so this point here would be 30 degrees, pi over 6. My horizontal distance to get out there is my long leg, square root 3 over 2. My vertical distance to get up to that point is 1/2. That same triangle gets represented out here. So now this angle here would be my 30 degrees. So if I'm working back, that's 150 degrees, or 5 pi over 6 radians. X would be negative. Oops, square root of 2. X would be negative. Y would be positive. translate it down here. Now there's my 30-degree angle. So that's going to be 210. 7 pi over 6 if I convert it. Both are negative. And then the last one. X is positive, y is negative. Okay. So what are we at now? Should be at 12 points, right? Okay, we started with 4. 4 quarters is 8. Now the 4/6 is 12. Okay. We got 4 more to go. But we've already done math. That's the cool part. Okay. Because let's see. So that just kind of got all kind of screwed up. That didn't work out for me at all. So let's start over from I want my triangle. Triangle. Look like that. Yeah. Yeah. So now, on my purple, now this is going to be the 60-degree angle. This is going to be the 30-degree angle. My hypotenuse is still going to be 1. But now, my short leg over here is 1/2. And my long leg here is now the square root of 3 over 2. Okay. Same triangle, because it's still a 30, 60, 90 triangle. Okay. Same triangle, just in a different spot. So that is going to give me this point here, here, there, and there. Okay. So this is 60 degrees, pi over 3 radians. The x and the y just flip around. because we've just inverted. We've inverted our triangle. So x becomes y. Add 60 more degrees to this one. Gives me 120 degrees, or 2 pi over 3 radians. Negative 1/2 square root of 3 over 2. Add 60 more degrees and I'm at pi. Okay, so that's straight out here. That's not going to help me. We've already found that one. Add 60 more degrees, so that puts me at 240 degrees, or 4 pi over 3 radians. Which would put me at negative 1/2 negative square root of 3 over 2. Add 60 more degrees, 300 degrees, 5 pi over 3 radians, positive 1/2, negative square root of 3 over 2. Add 60 more degrees, and we're back at 0. Or 3 pi, or excuse me, 0 or 360 degrees, or 2 pi. Yep. So when it's all said and done, this should be what your unit circle should look like. Yep. Give you a couple of seconds here just to verify all of them, but that's what your page should now look like. Yep. What we're going to do tomorrow and in the future is we're going to utilize that, and we're going to be answering questions that go along like this. What is the sine at pi over 6? What is the cotangent at 11 pi over 6, etc., etc., etc. And we'll be able to automatically go right out on it. Okay? One thing that I would put somewhere on your unit circle page, okay, is we should do this right off the start. Somewhere on your unit circle page, I would put these on there. That cosine is equal to x. You know, like either at the top or at the bottom. Cosine is equal to x. Sine is equal to y. Tangent is y over x. Cotangent is x over y. Secant is 1 over x. Cosecant is 1 over y. I would put those right on your unit circle